exams online.
I know what it is. I just don't have it.
Oh yeah, we were trying to do it, although I just we couldn't figure it out.
Okay, so what are we doing today? Anybody have any topics they wanted?
I think Kenna wanted to do
That's right.
period.
I knew somebody said something. I forgot what it was.
I'm glad because I know a decent amount about this. I think it's probably one of my more known things.
Okay, we'll go with that. Sure, why not?
I mean,
What are we doing?
then you need help with what's it called? Period
Waves?
stuff. Yeah.
Yeah.
Wait, I have a
Okay.
question.
I have an answer.
So since Friday's Good Friday, do we still have school or
No, you have Friday off.
okay?
Wait,
Yes.
what's Good Friday? Isn't that the Friday before
Easter.
Well, we know somebody's a
Mr.
heathen
Donald?
in this channel.
Bro, okay, dude, if it wasn't for me working at Walmart and they're having Easter stuff out, I would have no idea it was.
Bro, you're definitely a heathen.
Seriously, name it physics stuff? Question mark.
No. It's physics stuff, question mark, question mark, question mark.
Wait,
Okay,
where?
whatever.
I had no idea what we were doing today.
You go
Physics
on-
stuff.
If you go on his live, you can see it.
It's on the Twitch. It's on the Twitch.
Alyssa, where were you during math?
Bro, I just want y'all to know I stayed up till 4 o'clock. I got on for like a
You
good
fell
30 minutes
asleep,
and then
didn't
fell
you?
asleep in the middle of class and I was like, wow. And then I woke up at like 11,
Mr.
14.
Donald called you, and then you did not answer.
Bro, I'm sorry.
I see how it is, Speckles.
Bro, I
That's so
couldn't.
funny.
My
What's the
sleep
story
schedule
behind
is so
calling you
messed
Speckles?
up.
Because I don't
Speckles
understand.
is so damn
Her
good.
email address.
Her name is Speckles. That's all we need to know.
Speckles? Can I know why?
Because her name is Speckles. Just like your name is Hunter.
I didn't think of it like that. My bad.
Why is your name Hunter?
I was named that way.
Because he was born with it. Speckles was.
ready to kill.
He was
Speckles
not
was
born with the.
bestowed.
He was not born with the name Hunter. He was given the name Hunter, just like she has been given the name Speckles. She is Speckles.
Oh my god, I understand.
That's how you get a name. Okay, so quick. I assume you want like a general overview of waves, like the parts of a wave and stuff as well, kind of, or no?
Yeah, sure, I guess. Not sure.
You're the one who wants this. What do you want?
I need help, but
I'm so tired.
You people need to learn to either A, sleep better, or B, function on less sleep. One or the other.
No, I can
We're going
function
to
on
college
less
soon. We
sleep.
need to sleep
I'm also really hungry right now, so.
Okay, so also C, function on less food. That's a terrible wave.
Oh, wait, Evan.
I haven't eaten anything since like last night at 7 or something.
Well,
Evan.
that's not my problem.
Look at the Discord screen share.
Stop going live.
You don't have to
I like the new.
there, do you, I guess?
I like that you simplify.
I don't have to what?
What?
You were saying something, Kenna.
Oh, you don't have to do the diagram. I know what the amplitude and stuff is.
Okay, well I asked that and you said yes.
Jeez. Well, yeah, I was just like, you don't have to though if you don't want to like, if no one else needs it.
You're terrible.
I'll
So
take it as a refresher.
period.
Oh, never mind.
Too late now.
Just got erased.
It was actually erased like 5 seconds ago. Period. Frequency.
Or the least amount of delay here.
I have the most amount of delay because I don't even have it open yet.
Terrible.
You just erased. Oh my god.
Oh wow, that was a while ago.
Jesus, Kevin.
Alright,
Yeah,
so
really
you have period, you have frequency. You should know how they're related and what they are. Period is the amount of time.
It takes to do one full wait.
We don't want to just say it for waves, we want to say it in general. It takes to complete an action. To complete. If I can spell complete. In action. And when we say this, I started to write the word "n," like not even finish complete, because I put the "e" there and I started to write "n," and I was like, oh, so that's not how you write that word. But
Dante, Mr. Dom, you're taking after Dante with that writing.
yeah, So when we talk about completing an action, we're talking about an action that's something that's done over and over and over, such as a spring oscillating, a pendulum oscillating, anything that is done repetitiously, an object spinning around, etc., etc. So that's what our period is, and the frequency is the number of times something, or I guess instead of saying something, we'll kind of keep it the word, an action is completed per unit time. We tend to use seconds is completed per unit time. We tend to use seconds when talking about most things, but it doesn't have to be. It could be like per hour, per minute, things like that, such as we would talk about the frequency of the Earth's rotation is 1 rotation per day, basically. It's a little less than that, but roughly that's how we would say it. Or we could say the Earth rotates around the sun at a frequency of 1 time per year. Those are also frequencies. So it doesn't have to be per second. Now we're talking about our waves and things like that. We do talk about them in seconds, so that's where we use that for. We also have our period, for specifically for waves where we use our frequency and period is in v equals lambda f. And the reason we could use either one is because we should know that f is equal to 1 over t, and t is equal to 1 over f, where t is the period. Capital T is the letter we use for period. Since it is a time, we still use t for it, but we use capital T to represent that it's a period, not just a length of time that's passed by. So period we could measure in any unit of time, so like it could be like seconds or hours or minutes, etc. Frequency is 1 over seconds, 1 over hours, 1 over minutes, etc. because it's the reciprocal of it. Okay. When talking about our frequency for waves, we do measure that in hertz. And hertz is equal to 1 over seconds, which is seconds to the negative first. They're all basically equivalent when we talk about units. So you can have megahertz, gigahertz, picohertz, whatever you want to have. Millihertz, yes.
Big hertz.
No, small hertz. Okay. I'm assuming that's the kind of information you were looking for, Miss Kenna.
Yeah.
Is everything alright? You sound super silent.
I'm really tired still.
4 minutes
But yeah,
later,
that's a
I'm still
lot.
tired.
Nothing
No,
has
Dude, not gonna
changed.
lie.
I thought you were completely well rested in those 4 minutes. My bad. I thought learning physics would energize you.
I am currently on edge. It's
Can you
physics
guys
I do
like not
physics.
interrupt my class?
That toucan has
I
a
really
right.
thought she was talking to Hunter at first, and I realized there's people in her background.
Yeah, just my sister and my mom. Apparently they don't know how to talk to themselves without like causing a ruckus.
Can I get a room
All I
key?
can imagine is that like a minute from now, all we hear from Kenna's mic is just, and then the people in her background are really concerned.
Yeah, so-
Okay. I don't know what else you want me to do though, with waves and stuff.
The
Yeah,
toucan has
okay. I like
arrived.
some of the stuff. I just wanted to see how it was connected.
Thank
But I
you,
got
Twitch
it now.
Prime.
Okay.
I'll have it.
You guys can totally sub to me and donate money now. I've got 50 followers,
Oh.
so you wanna donate them fat monies or whatever they do, bits nowadays, whatever they're doing. I don't know.
Bitcoins.
Yeah, please don't donate anything to me.
Do you have a PO box?
No.
Ah.
Anything else anybody wants to go over?
No.
Oh, hold on.
Maybe.
Let me look at my notebook because I have something I want to go over.
I'm sorry.
I
I can.
feel like I'm gonna question everything about electricity. Anything
Oh
electric.
yeah, that is also something we should go over.
Okay, I
Oh.
mean, that's fine.
Like resistance and currents.
That's fine. I can do a quick overview of that again.
Series is the one that's all in like a one line, and then parallel is multiple different things, right?
Yeah, parallel is when you have a branch
Yeah.
off. Yeah.
Okay. Or at least some old ones.
So the top one, as it comes up on the screen, is your series. The bottom one is your parallel. As was mentioned by Hunter, remember the squiggly line means a resistor. So if you have resistors in series versus resistors in parallel, they have two different options. Remember, in series, these are the two formulas you get on your formula sheet for AICE, which is the only useful ones. So RT, somebody's watching something on TV, I'm assuming.
Evan.
So resistors in series are really easy. You just add them. So resistor total is just R1 plus R2 plus R3, etc. In parallel, however, it's 1 over RT is 1 over R1 plus 1 over R2 plus dot dot dot. So if you want to solve this one, the easiest way to do it is to say that RT is equal to 1 over R1 plus 1 over R2 plus dot 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 to the negative first. So you just reciprocate both sides. Hold on 1 second. So you reciprocate both sides. The one on the left is real easy. It's just RT. The one on the right, you have to be very careful. Do not just reciprocate each individual R1 and R2, etc. That would get you to a series connection. That's not how it works. You reciprocate the whole thing after you've added them together. Now, what's your question, Ken?
You answered my question.
Okay.
Okay, so in a reciprocal is
Yes.
just 1 over the value.
Of an individual item, yes. So you
Okay,
just take it and flip it.
so
Well, hold on,
in
careful.
series-
It's not one. When you say 1 over, you do have to be careful because you basically just flip it. So just to make sure. So 2/3 goes to 3/2. That is the same thing as 1 over 2/3. That does equal 3/2. So yes, that is a true statement. Just make sure you're careful on what you mean and say by that.
But so okay, how does like the 1 over 2/3 thing like work? Because I've always been confused by, or not confused, like
No one's ever probably actually showed you very well.
yeah, I was trying to avoid it as much as I can, but
So if you do 1 over 2/3 to get, you want to get the fraction out of a fraction. So I can multiply the bottom by 3/2. But if I multiply the bottom by 3/2, I must also multiply the top by 3/2. Well, on the bottom, what's 2/3 times 3/2?
equal
Yeah, what is it?
0.
No,
Or maybe, my bad.
1. So, and what's 1 times 3/2?
3/2. 3/2.
There you go. That's what you're actually doing. So there are shortcuts
Okay,
that
so
teachers
if
will
it's-
teach you and
if
things
it's
like
1
that.
over something, then okay, so if it's 1 over something, then the something will be like flipped around if it's a fraction, and then that's like the final answer. So like 1 over 1/2, it would be so that it would be multiplied by 2 over 1, so the final answer would be 2.
Yeah. So the shortcut that most teachers will teach you is with division with fractions, as I've illustrated. It should be popping up on the board any second for you guys now if it's not already. Most teachers will teach you keep, switch, flip, keep, change, flip, keep, flip, change. I don't care what they teach you. They teach you something though. But basically what you do is you multiply by the reciprocal of the denominator. And it's illustrated by this process here, because if I multiply the bottom by the reciprocal, I get 1. So that's always going to be 1 if I multiply by the reciprocal. So I just multiply the top by the reciprocal of the bottom, because this bottom calculation is actually irrelevant, because it's always going to equal 1 if you do it correctly. So most teachers will just teach you this part here, because it would be the same thing as this one, just not over 1.
Okay.
So that is why all of those processes that you've been ever taught work. They're just shortcuts that people don't really elaborate on usually.
Okay, so whenever in the parallel series to find the total resistance,
Mm-hmm.
you would need to find the common denominator of the two fractions of resistance 1 and resistance 2.
If you're doing it by hand, yes. Why you would ever do it by hand, I don't know. The calculator?
How else could you? Oh, how would
1/2 plus 1/3 plus 1/4 plus whatever, and then do the negative first power.
Oh. Oh, okay.
Yeah, your calculator do it for you, and you get a scientific calculator. So.
Okay. Could you please send out the thing, the link to the calculator on.
Yes, hold on, I'll send it right now so I don't forget.
You can send it later.
I'll send it because I think you've asked a couple of times. So.
I do need to buy one.
Um, I would suggest buying one. I will caution you. You're only gonna need it for high school. You'll probably never use it in college.
Oh, what?
A graphing calculator.
Aren't scientific calculators like $30 and then?
Scientific? You can get one for like $12.
Right.
And I would
I
very
know, like,
specifically
graphic
mention
calculators are,
$12.
like 100 or something.
Graphing calculators can be anywhere from about 100 to 130, 40 ish.
Alright, I need to buy one. I guess I've just been using Malone's.
Yeah, it's in the Discord. Yeah. But honestly, like I said, you're only going to need it for one course next year. So
What course
it's
is that?
whatever math class you take.
No.
I mean, if you're going to Gulf Coast uses them in their math classes. I don't know about calculus, but the other ones for sure, and probably calculus. But most universities, like when you go to a math class, most of them aren't going to let you use a graphing calculator anyway, to be honest. So honestly, I tell my students you're buying it for high school and for the AP test if you take like AP Stats or AP Calculus.
Is there a reason to buy a graphing calculator besides that?
No.
Why won't they allow you to use it on the test? Is it like something? Is there
Because they expect you to be able to do calculus and not rely on the calculator to do it for you. And they expect you to be able to do basic calculations without a calculator. I've never once in college, either my undergraduate or graduate, been able to use my graphing calculator. I've always been able to use only a scientific calculator.
Oh, okay.
Because they want you to be able to do that. And they don't really necessarily care if you can't like do the basic stuff. I mean, obviously, by the time I'm getting my master's in math, they expect I can do basic math, so that it's use scientific calculators. And usually in calculus, like at the college levels and stuff at universities, they let you use a scientific calculator to do those basic calculations because they expect you can do those. But they want you to do all the calculus and show all the calculus out and stuff like that. So most universities and upper level maths will not let you use them for anything. Physics courses, they tend to let you use them because they don't care if you can do the calculus. They want you to be able to do the physics.
Man,
So.
dude, the calculus is the hard part.
For some
Shame
people,
I can't do either.
it's. I wasn't gonna say anything, but okay. Yeah, he's in pre-cal. Okay. So there is your general series parallel connection for resistors. Make sure you can sum them up, etc., etc. My marker, which I left over here. So if it's we have a couple rules for in a general circuit. Remember that the double lines is assigned for a battery. So if we have like.
Oh, could you give us like a practice problem to do on the board?
We're just kind of working through stuff before we get to a practice problem. So
Okay, yeah.
let's just do like 3, 4, and 6, and 12. I don't know. So 12 volt battery, 6 ohm, 4 ohm, and 3 ohm resistors. So we can't forget that we can do a couple things to make this easy. There are some rules that we can use, but before we even talk about those rules, we can combine these resistors using these rules up here. So this circuit is equivalent to a 13 ohm resistor and a 12 ohm battery. We can combine those using our rules up here to say that those three resistors are equivalent to one 13 ohm resistor. And then we can use our equations, V equals IR, et cetera, to determine the current and all that kind of stuff.
Wouldn't it be like 1 and 1/12?
It'd be 12 thirteenths. So V equals IR. So 12 is equal to I times 13. So I is equal to 12 thirteenths. If you wanted to find the current.
Oh, it's 12 thirteenths?
Yeah. You'll see it on the equation on the right hand side in a second.
I see it, I got it.
Okay.
I was confused. I thought it was 11 and 2. Skipped on the easy parts. Could we do a parallel as well, because that one is a little bit more difficult.
You mean like the one I'm already drawing?
Like the one the one I see over your shoulder, Sunday.
Yeah. So again, keep the resistors the same, but connect them slightly differently, and ask ourselves, well, what happens to the resistance of the circuit? Do we think the total resistance is going to go up or going to go down?
It's gonna go down.
Okay. Why would it go down? What's the thought process there?
Because since the 6 and the 4 are in a parallel, they would add up to be lesser than just like a normal 6 and 4. So then, like, with that plus 6, or that plus the 3, then it would be less than the other one.
Okay, so
I
you're
don't
using...
have a lot of logic.
Right, so you're not using any logic, you're trying to show the math behind it. We want to have a logical reason of why does this give me less resistance, because that is the correct answer. So logically think about the last one. If you wanted to start at the battery and end at the other side of the battery, what did you have to do?
Go through resistance.
How much resistance?
13 ohms of it.
So you had to go through 3, 4, and 6. You had to go through all 3 of them. Now if I start at one end of the battery and I want to get to the end of the battery, do I have to go through the 3, the 4, and the 6?
No, just you can only get to the 3 and the 4 if
Or
the 3 and the 6.
so I either go through the 3 and the 4 or the 3 and the 6, but not the 4 and the 6. So I am actually incurring less resistance no matter which path I travel than before.
Doesn't it still go through both?
No, it'll go through either one. I can't go through both the 4 and the 6. I can only go through the 4 or the 6 at a given time. Now, could I go more laps around, which is kind of what electricity is, where it keeps just flowing? Yes, and at some point I may go through the 4, I may go through the 6. Think about it like traffic. If I have to go from my home to somewhere else and then keep going around and around, at some point I'll probably go from the 3 to the 4, and other points I may go from 3 to the 6 before I go back home or whatever. But at some point, any individual given point, I can only go through the 4 or the 6, but not both at the same time. It's physically not possible. But we can break this one down again using our rules here. So we have the 1/6 plus the 1/4. So RT for that will equal that. So we get, what, 12? So 2, 5, 12/5.
3/12.
So yeah, 2/12 and 3/12, which will get us 5/12. Do the reciprocal, we get 12/5.
And
That's just for these two. So this will go to, yeah, it's 2.4.
so it'd be 5.4 as opposed to 13.
Mm-hmm. So it'll look like this, which then goes to,
partial credit.
was it 15? So 27. This
27.
over 5.
Oh, right. Okay, you didn't draw it yet. I was really supposed to be at 27.
And then again, we could figure out the V equals IR, et cetera, et cetera.
Okay, could we get a practice problem?
No. No practice problem for you. Just test problems from now on.
Hunter, turn off your Twitch. We're gonna get the word answer practice problem.
Does that make sense to everybody else, though? Because Hunter is the only one talking, so I just want to make sure everybody's okay.
Okay, I'm piggybacking, carrying the team.
I don't know. I should be kind of scared if Hunter's one carrying the team, guys. You might want to step your game up.
It's because Dante's not here, unless that's him who just.
Oh, somebody just joined. Is that Dante?
No, it's Damien.
Oh, it's Damien. Damien's here to carry the team now.
Okay, hold on, I gotta go to Twitch. Were you still clearing out the shed, or what were you doing?
Alright. So, with that, whoever's got the TV going sounds like Chris.
Yes, me.
Yeah. It's Chris thing.
Okay, you still haven't muted yourself, bro.
Oh, yeah.
He's like, yeah, it's me. What's up? I'm just gonna keep it open here, let you listen to whatever show that's on.
I'm not. Don't let him.
What are we doing? We're doing waves, right?
No, we did waves already. We're circuits now.
I asked for seconds.
Oh, I forgot. I almost said.
Yeah, please don't do that. I don't want to get banned from Twitch.
Frig.
Alright, so now we're going to talk about is how, before we do any practice problems, is how this all works and goes together. So we have to remember, we talked about, so we know how to combine our resistors, now no big deal. But now we want to talk about the currents and voltage drops and things like that. Back to our, we had two main rules that we used. So we're just going to call this actually V1, R1, R2, R3. So we're not going to be given any numbers here. We're just going to talk about what happens across as I move around the circuit, move through the circuit, and things like that. So we have to remember there are two rules that we have followed. Does anybody remember those two rules?
Ohm's law and
Hooke's law.
Hooke's law is for spring. Nice try. Ohm's law we're not going to use here necessarily. We will use it, don't get me wrong. But when talking about a circuit, we're not going to be using Ohm's law necessarily.
Kirchhoff?
That is correct.
Yes.
Kirchhoff has two rules. Do we remember either of those rules?
I have no idea.
Total voltage around the loop is equal to the total voltage from the battery.
Something along those lines, but that's a loop rule, yes. I'll give explicit definitions in a second, but loop rule is one of them. So going around the loop, so very good. Anybody remember the other one besides Damien?
Whatever the sum of the current entering is the same when it's leaving.
Very good, and we call that our junction rule.
What was that rule again?
Okay, so I'm going to explain both of them. So you should. I'm not going to write it down because it's a little bit wordy, but you should have these written down somewhere already. If not, go ahead and write them down on your sheet. So your loop rule. When I go around a loop of a circle, or of a circuit, not a circle, then I get the sum of the voltages equal to 0. So again, the loop rule, when I go around a loop of a circuit, which means I start and end at the same place, that's what a loop is in case you don't know, the sum of the voltages is 0. And with that, you might want to put notes out to the side or anything. Remember, batteries give a positive voltage if you go the right way, and resistors give you a negative voltage if you go the right way. If you're going the wrong way, it reverses that. Okay, and then junction rule, as Kenna very well put it already, the sum of the currents going into a junction is equal to the sum of the currents leaving the junction.
Well, I'm still on the loop rule.
Can you repeat the battery thing? Batteries give positive.
If you're on the right direction. So batteries,
Okay.
we say when we go across a battery, we say it would give us positive voltage. But we can have, remember, so batteries have a directionality to them.
Okay.
So for instance, if I have what I drew up here on the left, that is two batteries facing each other. So I can't add both of those voltages because one I'm going the correct way, one I'm going the opposite way, no matter which way I travel. So for instance, if I give like this one 6 volts and this one 12 volts, that in essence is the same thing as saying a 6-volt battery fighting a 12-volt battery. Well, the 12-volt battery is clearly going to win, but it's only going to win by 6 volts.
What was the junction rule again?
Junction rule is the current going into a junction is equal to the current leaving the junction. So, and very specifically, we talk about the sum of the currents, because you do have more than one current coming and going in a lot of cases. So the sum of the currents entering a junction is equal to the sum of the currents leaving the junction. And remember, as we talked about your current direction, because that is kind of important, which way is the current going?
Are we talking about the?
Are you asking us or are you telling us?
No, I'm asking you, which way does current travel?
Positive or negative to positive.
Negative to positive, do we agree?
I do.
I remember I said positive negative one time, and then I can vaguely remember you saying that's not it, but I may be wrong.
Travels to the greatest resistor, or not the greatest, the least resistor.
Goes from positive to negative.
Okay, so the question is, because Hunter said goes from negative to positive, and Alyssa's now said positive and negative. It's obviously the only two options. The question is, which way does it go?
Positive, negative.
Positive, negative.
And
I
Hunter,
feel
you,
like what I said is a dumb answer.
Hunter sticking with negative to positive?
I'm going with Alyssa.
I vaguely remember saying positive and negative and then getting completely shut down. So I'm gonna stick with my answer.
The answer is...
In the nicest
Wait, wait,
way.
wait, 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 wait. O'Donnell, do you want to know how it actually flows or how we draw that it flows?
I just want to know how it flows.
You want to know how it
Okay.
actually
Like,
flows?
I got this from.
The
Okay, it's from negative to.
the answer
I got
is
my answer from the book.
you're both right.
What was it?
You're both right. And Evan pointed that out very astutely by thinking about it. Depends on if I'm asking the question, which way does it actually flow? Or which way do we draw it flowing?
I tried to say it 10 minutes ago, but my
You
mic was
draw
muted.
it.
I've been like screaming, and I was like, nobody's listening to me.
We just all put you on mute just to mess with you for the day.
O'Donnell, can you please just mute Evan from the Discord?
Wait,
I can, yes.
The server deafened me, so I also can't hear.
No, that's no fun. You can listen to Twitch still. All right, so the...
Bans me from the Twitch.
Alright, so current actually flows. We know this now. Flows, it's the electrons flowing that create current. So it's the way that an electron would move is how current actually flows. So in our diagram down here at the bottom, it flows out of the small end and around the circuit. However, we did not know this. I don't know how many years ago when they figured this out, to be honest. But we didn't know this when we first started doing electricity and having electricity and performing experiments, etc. So people were just like, oh, it's protons. Protons are the ones moving for whatever ungodly reason. So let's make it the way the protons would move. So when we draw a circuit, we actually draw the current flowing out of the big end. Goes this way, splits here and here. Goes that way, back in, back in, back in. So that's how we would draw the current flowing in the circuit. However, as we now know, it is backwards. Yes, we know this. But it really doesn't matter. It's arbitrary. Just like when we talk about which way is positive, which way is negative. Well, I can pick whichever way I want to be positive, whichever way I want to be negative. It's just done by convention that we say it flows out of the big end and into the little end. Okay.
Oh, O'Donnell.
What?
Can you let me anything new about AICE? Like I remember you saying last week they like send out some Tuesday.
I have not heard anything. Let me check. I'll check the thing real quick while we're doing this. Let me pull up the page real fast. Because that's a good question. I forgot they were supposed to put something out today. Because last time they didn't put out a whole lot of information. So if we look at our circuit as I have it drawn now, we want to flow out of the positive end. We're going to go around, hit R1 or R, and then R2 or R3, and then back to the battery. That is one full loop. Excuse me. Okay, news. I do not see anything updated for today yet. Nope. Okay. So when we do a loop, I don't know if you guys will be able to see the other colors or not. I found out in pre-calc that they can't see the different colors.
I am many seconds behind.
Like 2.
Restart Twitch.
So we have the...
It's like a 5 delay. That's what Evan might have.
Yeah, we got that Ethernet.
Oh yeah. Get that laughy tone.
I'm going to hope everybody's on Ethernet, not Wi-Fi, because Wi-Fi sucks.
It's not even on.
Right. Okay, so we have two options. I'm not sure if you can really see the colors. You can probably see the red, maybe, but the green's really super light.
Did you just draw in gray? Ghost marker.
He's a fan.
Dude, Arc is only a third of the way done.
Okay, so you can have the red path or the black path. Those are what we call loops. So as you go around a loop, if you have to split anywhere, you have to create a separate loop for that. So this is where we have the junction rule that comes into play for that. So when I talk about the loop rule, I always start at my battery. So I use it and then go around and end right before my battery. So I always start like quote unquote right before the battery. So if I use the red path first, I'm going to hit the battery I'm going the proper way, so I'm going around this way, so battery V1 will give me positive voltage. And I'm going to add R1 times, or actually I'm going to subtract them, make it easier on you guys. So because I'm going across this resistor, remember we talked about when you go across resistors, if you're going the proper way, you have a voltage drop, so you lose voltage. So it'll be minus what I'll call I1, R1. Then what happens in order for me to get to R2? What do I have to do?
You have to split.
I have to split. I have to go through a junction. So I can't have I1 again. So when I split, I'm going to have two different currents, one going up and one going down. So just to make things easy, I'm going to call I2 R2. And then on my way back to my battery, do I hit any other obstacles?
Hold on, I gotta restart Twitch.
Again?
Twitch is just not working for me right now.
That's unfortunate. Okay, so as I go through R2, after I hit R2 and go back to the battery, do I hit any other obstacles?
I mean, it comes back as I.
But do I hit any other obstacles?
No.
No. Well, obstacles being things on the circuit. Do I hit anything else on the circuit? I'm gonna. After I've gone across the battery, then R1, then R2. As I go back to where I started, do I encounter any other obstacles? Is what I would call them, or circuit parts, or whatever you want to call them. It doesn't really matter. But do I encounter any other things at all? No. So then, my loop rule now that I'm done with, when I add up all the voltages, I have to get an answer of 0. That is one option. Now I can take the other path, being the other loop, do relatively the same thing. I get V1 minus I1 R1. But now I'm going to go through R3, so I have to have I3, because that's a different current than going through R2 possibly. And then again, so I get relatively the same thing. However, I get that I3 times R3 in this case, because I went through circuit 3. Okay, so that is how you use the loop rule. The junction rule is talking about currents into and out of a junction. So if we look, there's only one junction that ever happens, and it's actually there's two, but there's one important one we'll need to talk about in this one, which is when I1 goes into the first one where it splits to R2 and R3. Well, our junction rule says the current in, so I1 is coming in, has to be equal to the sum of I2 plus I3. Damon, your mic's staying constantly open, sir. Okay, so does that make sense? You can't just nod your head. I can't see that.
To be fair, I wasn't paying attention at all.
To be fair, that's not good. I asked if all of this makes sense.
Sorry, yeah, my grandmother walked in. Yeah, it looks all good.
Okay. That is how you use your loop rule and your junction rule. Now, a couple of things that are really important to point out. If I look here at these top two equations, we can do some math and figure out that obviously these two are the same as these two. So V1 I1 R1 is the same as V1 I1 R1 in the first two equations. So what does that mean about I2 R2 and I3 R3?
Yes.
I figured that would be the response, so don't worry, I got you covered. So let's pretend we found these numbers. Yeah. You guys have got to pay attention. I'm tired of hearing this what is the question thing. It's not fun to hear. Okay, so illustration of, let's pretend I know what V1 is and what I1 R1 is. Let's say I know that's 12 and 4. So on the left there over there. What do I know about I2 R2 and I3 R3.
They must add up to equal I1 and R1.
Not quite.
That's a lie. Nope. They must be equal.
They multiply to equal.
No, they are equal.
Why are they equal, Hunter?
Because if they are added, or if they are subtracted from. Okay, because like they must be equal because they both have the same product when you combine it with everything else. So if they had two different values and you get two different final answer. You know what I mean?
I do. It is very hard to explain. It's one of the things I'm trying to get you guys to do is explain those things. Sometimes the basic things are some of the hardest things to explain, but we have to be able to explain them to say this is why. So what he's trying to get out is that V1, I1, R1 is the same in both equations. So the beginning part's the same, regardless if it's actually 8 or not. Can I subtract something from the same number and get 0, and then subtract something different from that same number and get 0? In other words, can I do 8 minus I2 R2 and get 0, and 8 minus I3 R3 and get 0, and these two be different numbers?
No.
No. Mathematically, it's impossible. What that tells us is that I2 R2 has to equal I3 R3. So we get a nice, lovely relationship there, and that is one of our rules that we've talked about. And that is, when we talk about this, make sure you write notes if you don't already have this somewhere for your circuit stuff, is that the voltage drop in parallel is the same. So what I mean by that, if the V1 is 12, R1 is 4, that means when I go across R2, I have to lose 8. Or when I go across R3, so the top branch, I also have to lose 8. So the voltage drops across parallel branches has to be equal. If it's not equal, we violate all the rules of circuits.
And that's not the same as series circuits, I assume?
No, that is not the same as series circuits. No, most definitely not.
I have the hardest time spelling
Parallel.
I know, but I always end up with like 4 L's.
No one's going to see it but you. It's okay. But yes, that is not necessarily true in series. So if it was to be, technically, if I look at this circuit, Damien, R1 and R2 are connected in series with each other. And the voltage drop across R1 can most definitely be different than the voltage drop across R2. However, when we talk about the voltage drop across R2 and R3, because they are the entire branches of parallel, those voltage drops have to be the same. Now, does there have to be the same amount of current going through them? So in other words, does I2 have to equal I3? And correct. So as long as R2 and R3 are different, the answer is no. So again, mathematically easy to prove. If I know the values for R2 and R3, I know exactly what that these are different values, because then I2 and I3 can't be the same. So for instance, if I say I2 times 2 equals I3 times, let's just say 4, then clearly I2 and I3 can't be the same thing there. That's a quite easy mathematical thing to look at and say. So as long as the resistors have different values, the currents in those will also have different values. Does that make sense?
Did you just randomly assign 12
Yes.
and 4?
I randomly assigned everything.
Okay. I can't really put a variable there.
You can. It's called V1, I1, I1. But you guys don't see it that well. That's what I'm saying. That's why I gave it numbers to help you guys out. So when you first learn things, adding numbers and putting in numbers, like we talked about, remember I told you guys, if they don't give you numbers, you can pick numbers in a lot of things. If they don't give you a battery, pretend your battery is 6 or 12 or whatever you want it to be, and then figure out what the math would be, and then you can apply that. But that is the kind. That's the idea.
Because usually for variable I put X, but then that would be weird because you're using letters as its own variable.
Yeah, the problem is it has two variables to figure out what that is. Technically, it's called V2. It's the voltage drop. But we use 2 letters to figure that out. So, all right, homework problem time.
Alright.
Speaking of homework, did we have one last night?
No.
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 Okay.
It's gonna be fun.
Can somebody please take a screenshot of this and just put it in the Discord?
Chris.
Yeah, that's what I was gonna. I didn't want to point out Chris, but yeah.
Why can't it be somebody else?
Yeah,
No,
but
we
like,
can't.
it's his thing.
That's apparently his thing now.
Chris, do the thing you do.
Dude, I already forgot how to screenshot it.
Print screen?
Print screen.
You forgot to say function?
12.
No, I
Huh?
didn't.
You said you forgot to say function.
You
No.
might have a screwed up keyboard then.
No, I have a. Mr. Donald, you saw my keyboard. It was like the.
I did not
actually,
see
no,
your
you didn't.
keyboard.
Well, it's basically just like a $10 one that is a wireless keyboard and the wireless mouse that you have to plug in the thing for the thing.
Yeah, it is a fucky one.
Whoa, dude.
You said it too.
He said
Your
funky?
keyboard does
What did
not
you say then?
glow.
It's
Rainbow.
I said function.
Are you really a gamer?
Oh, that's
Yeah.
not what I heard.
I said function.
I sincerely apologize.
Alright,
You guys forgot the.
Mine's pastel rainbow. That looks cool.
mine doesn't glow at all, because I don't really care.
I need to get a wired one because I'm running
Mine's
into
green.
light addicts.
For your keyboard?
Yeah.
And mouse.
No, my mouse. I have a decent mouse because at first I was getting a laptop, so of course I didn't need to buy a keyboard, but I got a nice set of headphones.
Mouse.
Is that a 5 in the middle?
Hunter, you should get the K95
Yeah.
Platinum. Gunmetal
I-
gray.
Okay, there is your circuit. It's not
Or
super
cheaper.
difficult, I'm not going to lie. Find the current through all resistors. Oh, and make it easy. Find current. And voltage drops. It's not a lot of extra work, but make sure you know the difference between the two and exactly how to find them. I would also highly suggest finding them in the order I
I would
have.
suggest turning the TV down in the background.
That would be Chris, I'm assuming, or Damien.
There are the
So that was me first.
Yes, you should know
Okay,
if it's
who-
above a
you
battery
said-
or a resistor what they are.
Saved it one time. Wait, which screen did it take a picture of? Oh,
The
it's
one.
your phone, don't worry.
Yeah, it's both.
Oh,
You gotta hit Alt or Control. Oh, Chris, too early on the screenshot. Too early.
Chris, oh my. Hold on, I have a screenshot, but it's both of my screens, so you'll have part of Discord open. Here, I'll send it.
wait, is that the homework?
Yeah, it's super easy. Shouldn't be too hard. But you should also
Going until tomorrow.
no. I'm getting ready to close it so I get your screenshot.
Hold on, I gotta. Oh wait, I can just drag it over to Discord. That's right. It's cool. Here
Discord
you go,
is
gamers. I
double.
put it in.
Can I
Thank you,
leave?
gamer.
It may be kind of small.
Why is your... Oh, Jesus Christ. You don't even have your monitors leveled.
I tried. Hold on.
God, you're terrible at this.
What did you
And yes, you can leave. Class is over.
Thank you, Chris.
No, Chris, delete it.